Today we're going to be working with linear programming, and it combines the past couple sections that we've been working on. And so we're going to start off with given the function, and this is read as f of xy equals 5x minus 2y, and we're asked to find the value. Well, I'm going to stop us there for a little bit, and we've seen something like this before where f of x equals 3x plus 4, where they give us f of 3, all right? This 3 is taking place of the x, so I'm going to plug this 3 in for that x and go 3 times 3 plus 4, so we have 3 times 3, which is 9, plus 4 is 12, so f of 3 gives us 12. So now here, it's the same principle where we have the function f of negative 2 and negative 6. Remember, that is a x and a y, so I'm going to plug this x in for that x and this y in for that y. So we have 5 times negative 2 minus 2 and then times a negative 6. Now I'm going to show my work here. We have 5 times negative 2, which is negative 10. Here we have to be careful because it's a negative 2 and a negative 6, which gives us a positive 12. And so we have the function of negative 2, negative 6 gives us a positive 2. And one more time, same thing down here. We have f of 3 and negative 2. Again, we have an x and a y. So I'm going to plug this x in for that x and this y in for this y. So f of 3 and negative 2 equals 5 times 3 minus 2 times a negative 2. Again, I'm going to show my work. 5 times 3 is 15. Negative 2 times negative 2 is a positive 4. 15 plus 4 is 19. And to be mathematically correct, I guess I should go f of 3 negative 2 equals 19. Next guy we're going to handle is we're giving a region with vertices, and we're asked to find the maximum and minimum values of these vertices. So remember that these vertices, all right, they are coordinate points, and they are x and y. Well, look at our function. We have a function of x and y, which equals x minus 3y. So my coordinate point 0, 0, I'm going to put in 0 for x minus 3 times and 0 for y to get 0. Next guy, again, I have a coordinate point. I have an x and I have a y. So my coordinate point for 0, I have an x here and a y here, so I'm going to just plug in my coordinate point. 4 minus 3 times 0. 4 minus 0 is 4. Next one. Again, I have a x and a y, coordinate point 5, 5. I'm going to plug my coordinates into this function and have 5 minus 3 times 5. 5 minus 15 is a negative 10. And last but not least, I have 0, 8, another x and y. I'm going to plug this 0 and 8 in for this x and this y. So coordinate point 0, 8 gives us 0 minus 3 times 8, and that gives us a negative 24. Now our question is asking for the maximum and minimum value. So what is we're going to start with minimum. What is the minimum value? What is our smallest value? That's going to be negative 24. What coordinate point gives us negative 24? That is 0 and 8. Right? We have to be careful because the question may ask what coordinate point gives us our smallest value. If it asks for the coordinate point, our coordinate point would be 0, 8. In this case, it asks for the value. The value is negative 24. Now, what is our maximum? Our maximum is 4. What coordinate point gives us our maximum? That is 4, 0. Now, to everybody's favorite, we're going to get to graph here. Now we're given a system of inequalities, and we're going to graph these inequalities, find their vertices, and then plug them in to this function. So we're going to start with y is greater than or equal to 2. we need a line, a horizontal line right through 2, which is already there for us. And now we are going to shade that line. Remember, I like to pick 0.00. You can pick any other point you want, but I like 0.00. So I'm going to put 0 in for y. Is 0 greater than 2? No, it is not, so I'm going to shade away from the point I picked. Next, I'm going to do the blue equation. Y is less than x plus 3. So I'm going to put a point, my y-intercept at 3. I'm going to go up 1, over 1, put a point, up 1, over 1, put a point, up 1, over 1, put a point. I'm going to connect the dots with a blue line. Ooh, not the best blue line, but it'll work. And then finally, we get to our red equation where it's 1 is less than or equal to x is less than or equal to 5. Well, in case we're struggling with all these numbers, I'm going to cover one of them up. So we can handle 1 is less than or equal to x, right? We just need a vertical line through 1. And see if I can get that more where it's supposed to be. Right about there it is. And now I'm going to cover the other side up. Now we have x is less than or equal to 5. And so now I'm going to put a vertical line through 5. 1, 2, 3, 4, 5. Or through x is 5. And there it is. Again, I'm going to line that up a little bit. Now, where am I shading on this red line? So I'm going to put, again, I like 0, 0. It just makes everything 0. So 1 is less than or equal to 0. So on this line is 1 less than or equal to 0. It is not, so I'm going to shade away from the point I picked. So I would be shading that way. And then if I have this side, x is less than or equal to 5, if I put 0 in for x, is 0 less than or equal to 5? It is, so on this line, I would shade towards the point I picked, which is that way. Now I'm going to jump back to the blue line here real quickly. Again, I'm going to pick the origin 0, 0, plug that in for my y, plug that in for my x. 0 is less than or equal to 3. That is true, so I'm going to shade where it's true, shade towards the point I picked. Now it's hard to see, which is probably the toughest thing, or one of the tougher things about these sorts of problems. Where does all the shading go? Right? So I have arrows pointing down in the middle, so I know I have to shade in the middle of this somewhere. Well, I can't go below this black line or above this blue line, so I'm going to shade in this whole region right here. So I'm shading in this whole region. But it asked us for the coordinates of the vertices of the polygon. This, I'm going to call it a trapezoid, gives us 1 vertice, 2 vertice, 3 vertice, and 4. It gives us 4 vertices. So we are going to take these vertices. This guy is 1, 2, and this vertice, 1, 2, gives us a value when we put it in here, and I'm going to write the first one out for us. 3 times 1 minus 2 times 2. This gives us a value of -1. Here, this is vertice 2, 3, 4, 5, 5, 2. So 5, 2 is another vertice that I'm going to put over here. And that's going to give us 15 minus 4, which is 11. The next vertex is all the way up here, which is 5, 4, 5, what? 5, 4, 5, 6, 7, 8. 5, 8. So now I'm going to put 5, 8 for my vertex. And so I'm going to get 15 minus 24. 15 minus 24 is not 24, I apologize. It's going to be minus 16 equals, and that is a -1. Last but not least, we have coordinate point 1, 4. And so see if I can fit that in here. Coordinate point 1, 4, I get 3 minus 8, which is -5. Now, my minimum value, we are asking for minimum value. What is my smallest value? My smallest value is -5. Maximum value, what is my biggest value? Here it is 11. And so I put my values. So that concludes our lesson. I hope this helps you better understand linear programming. If you have any more questions, please ask, or come in the morning. I'm available after school. But any questions, please ask. Have a great rest of your day.